Hi, I'm Ken Shackle, and I'm here to talk about plant-based tools for improving water use efficiency, which hopefully means you're there listening. So let's get started. One rule that is important to keep in mind is that plants use a lot of water in order to be productive. The sugar that's produced in leaves requires a lot of loss of water, and the reason why is because leaves lose water through the same openings that this carbon dioxide has to be taken up in order to produce the sugars in the first place. Another rule is that water movement through a plant is being pulled, not pushed. So evaporation pulls the water out of the plant. And this means that the plant water is almost always under a state of tension. The scientific term for this is water potential, but it's essentially a suction. And this suction gets pretty high, especially when the soil gets dry and starts pulling its own suction back for water out of the plant. So an example of this is in very dry soil conditions, the suction will be high enough to pull water out of the cells of the leaves and cause leaves to wilt. Of course, wilting is a very severe example of stress. And one of the questions is there something we can measure in the plant that indicates its stress before it gets so severe that the plant is wilted? Well, if you use a Google search and look for how to measure plant stress, you'll see lots of things. There are many technologies, some are old and some are new, and some are coming up all the time. I'm going to focus on just two classes of approaches. One is what I would call a direct approach, and one is an indirect approach for measuring plant stress. The direct approach is to measure the suction, and that's measured in a pressure value called bars. The indirect approach is to measure something about the plant that responds to the suction or that we think responds to the suction. So I'll talk about the direct measurements first. And there's a number of ways that water potential, or now we usually measure stem water potential. So that's what I'll refer to SWP as stem water potential. And there are many producers that already commercially make devices to measure stem water potential. The pressure chamber or pressure bomb, the stem psychrometer, the osmometer, and the microtensiometer are two new arrivals, more or less, on the scene of measuring water potential. Now, the principle of operation for each of these devices is very different, and some are more sensitive to temperature, for instance, than others, but they're all based on sound science. So one advantage to using stem water potential is that we have reference values, which we call baseline stem water potential values. And what these mean is that if you go out and measure a walnut tree in this case, and the temperature is 30 degrees C, and the air is somewhat dry, 20% humidity, and you measure a value of 5 bars, then what that means is that this tree is having the tension that would be in that tree because of the weather, even if it was in wet soil conditions. So as far as the tree is concerned, it has access to plenty of water. Even if you think the soil looks dry, and if all your neighbors are irrigating their walnut trees, the tree is telling you that it is not stressed at that time, at least not in a way that you can change if you irrigate it more. So it's probably a good idea not to irrigate. Now, we also have for walnut and other crops a series of stress symptoms that are associated with different levels of stem water potential. And this is an example table for walnut. We also have examples for almonds and prunes, and some people have developed some for other crops. So these are guidelines. They're good, useful values to get an idea about what level of stress you might expect, what symptoms you might expect for the different levels of stress. Now, those are the direct methods, but the indirect methods, there are too many for me to even talk about. There are methods that are on the plant. There are methods that are just above the canopy, taking pictures of the plant, flying around in the air on airplanes or drones, or orbiting the planet and satellites. Now, the hope that is that these methods will be closely related to stem water potential, but that remains to be seen. I'm going to give one example that is on the plant that is a commercial dendrometer. So dendrometers have been around for quite a long time and have been automated for some time. This particular one works on the trunk, and you see a picture of it there. But there's also ones that are connected to the fruit or leaves, or you can measure the distance, you can measure the size of many plant parts, and they all more or less show the same patterns. Now, these patterns are quite interesting, but I call this measure of stress as indirect because the patterns have to be analyzed to figure out what the stress level is for the given level of growth and the shrinking and swelling that goes on over the course of the day. So it's not just one measurement of stress, it's a derived measurement of stress. So that's why I'm calling it an indirect measure of stress. For instance, the Phytech devices that I'll be talking about have a stress value that goes from 0, which is very stressed and the plant is not active, to 100%, let's say, where the plant is very active, fully active. So they call it a plant status. Okay, so all of these plant-based approaches, whether they're direct or indirect, require a different kind of thinking if you're going to use them for irrigation management than the ET and water balance approach. And that is, they don't tell you how much to apply or how to schedule it. They only tell you if what you're doing with your irrigation is accomplishing what you want to accomplish. So the big questions that we have now are whether all these methods give you pretty much the same information or not, and also whether any of them are better or the same as an ET water balance approach to irrigation. I'm just going to focus on this first question for the rest of this talk, and we'll have another question for the another talk for the second question. Okay, so do all methods measure the same level? We've been doing research for a number of years in an almond orchard that you can see there in the Central Valley. And we have been looking at lots of measures of water stress, both direct and indirect. The ones that I'm going to talk about today are these three: the pressure chamber, the microtensiometer, and the trunk dendrometer, because the osmometer approach didn't work out very well this year in almonds. And I'm going to focus, just to give an example, just in the early season, May, June, that is late spring, early summer, so you can see the kinds of information that these devices are giving us. Okay, so for this period of time, for May to June, as you see in the graph down there, the baseline varied between about 6 and 12 bars, depending on the weather. So this is what you would expect for the stem water potential of an almond tree, even if it was in fully field capacity, saturated soil, let's say, wet soil conditions. Now, the pressure chamber, which is the black open circles and the black lines, was very close to the baseline value. That's the pressure chamber, was very close to the baseline value in early May. But as time went on, it got to drier than the baseline substantially, in some cases, reaching kind of moderate stress levels in June. So there were some times when there were increases in the pressure chamber measurement, and there were some times when there were decreases in the pressure chamber measurement, but those were always parallel to the trends in the baseline, which means that those were just measuring what the effects of the weather were on those plants. However, there were other times, such as C and D here in this graph, that were definitely not accounted for by weather. In the case of C, the weather was fairly stable during that time. The baseline was stable, and the trees were declining. And in D, if anything, the weather was getting less stressful, and yet the trees were getting more stressed. So those were not due to weather effects. But when you look at the irrigation values, which are in blue on the bottom of the graph, you see that there's a general pattern that those increases in water stress were being caused at the end of the irrigation cycle, when they approached the last day before they were going to get irrigated. But it's not always clear, because these values from the pressure chamber were only done periodically. and were not done on weekends. Well, okay, so the fluoropulse sensors were collecting daily data, and they were automated, and so we were able to see very clearly that each irrigation cycle was associated with an increase in water potential and then a decrease. So as I pointed out before, you can see in these two highlighted boxes that as soon as trees were irrigated, they recover in water potential, either at or above the baseline. And then after a few days, they start back down and start to get more stressed. In many cases, surprisingly, the recovery lasted only a few days, even when we were putting on 100 millimeters of water, which is in that third box that you can see on the graph. The trees recovered right away, but they also started declining fairly quickly. Now, what we learned from these sensors was that we needed to increase the frequency that we were irrigating, not necessarily the amount that we were using, in order to prevent these swings of being very wet right after an irrigation and very dry right before the next irrigation. You might call that the feast and famine cycles. Even though we had a deep soil, and it was a sandy soil. Now, and this was particularly important for another purpose, and that is when we use regulated deficit irrigation to achieve about a 14 to 18 bar level of stress in almonds in order to protect them from the hull rot disease when it's during hull split. I'll talk about that in another talk, but that happens in June and July. So what about the indirect measurements? The dendrometers that we used showed very similar cycles of stress as the microtensiometer, as the fluoropulse, but they tended to show more sudden drops from a level close to 80 to a level close to 0 without a whole lot in between. But basically, they showed the same level. So this is good confirmation that the plant is measuring stress and it's behaving stressed, at least in terms of what the dendrometer shows. So in summary, I think we will achieve the highest water use efficiency when we can get the plant to do what we want with the least amount of water. But the important thing is to understand what the plant is doing and what you're trying to have it do. At this point, we have proven manual tools, the pressure chamber with stem water potential, and there are promising automated tools that either directly or indirectly measure that level of stress. And I think that the daily values, whether they're automatic or manual, will really help to understand how to schedule irrigations and whether your trees can deal with a much longer irrigation frequency or need a short irrigation frequency, when they do need and when they don't need water. And this means you can dial in your irrigation management for each particular orchard. And whether or not this was going to result in less water use is a very interesting question, but I think it's an open question. For sure, it's going to let us use water most efficiently. At a later time, I'll talk about how we have used these devices to help us improve our efficiency by irrigating when we need it and not irrigating when we don't need it. Thanks very much for your attention.